So example 6.5, three parts of a single phase electrical system are designated A, B, and C. That means this part is A, this part is B, this part is C, are connected to each other through transformer as shown in figure. The transformer are rated as follows: A to B. That means this transformer is 10,000 kVA. That means 10 MVA. Remember, this is 10 MVA. And 138 to 13.8 kV. That means here you have 138. Here you have how much?
13.8.
Not necessarily, right? Because I believe this one is 13.8. Because they have written something like this 138 by 13.8, but I believe this one is 113.8. I'm not sure. Normally, bam pashetta age lekha hoy. Normally, the left hand side is written first, then that one. But I'm not sure why they have done that. This one is 138.
Sir, 1:10 লেখা আছে উপরে.
1:10. Yeah, 1:10. That means here you have 1, here you have 10. That means 10 times. So this one is 13.8, this one is 138. Yes, then here the voltage is still 138, right?
Yes, sir.
Because here, whatever the voltage you have here, that voltage will be here as well, because the same line. Then it will be step down, B to C. 138 to 69. Here the voltage will be 138 to 69. Again, 2:1 is written, right? Understood? Okay. So yes, then, first one has a leakage reactance of 10%. Second one has a leakage reactance of 8%. If the base in the circuit B is chosen as 10,000 kVA 138, find the per unit impedance of 30 ohm resistive load in the circuit. Refer to the circuit C, B, and A. Okay. So let's go there and draw the impedance diagram neglecting the magnetizing current, transformer resistance, and line impedance. Determine the voltage regulation if the load is 66 kilovolt with the assumption that the voltage input to circuit A remains constant. So আমাদের এখানে বলছে what is your base? Your base is circuit B parameters. That means 10,000 kVA and V base is 138 kV, right?
Yes, sir.
This is for circuit B. This is for what? Circuit B. Okay. Circuit A, circuit B, circuit C. So you have three types of calculation here. In this case, your V base is how much? Okay, since all of them are red, I'm going to change my color. Circuit V base is how much?
138.
138, that is given, right? And for these, S base is always same for all sides. S base is same. Now here, for circuit A, since you have a step up transformer, because circuit A to circuit B, that means step up. So it will be 10 times less. 10 times less. See the calculation. 138 into 13.8 divided by 138. Do you know why is that? Because see, here the base is 138. You have to back calculate how much volt you will have here for 138. It is 10 times less, right? Remember, if the base was 150, যদি এখানে base 150 হতো base, but the actual value is how much? Actual value is 138, right? This is the value is 13.8. But by any chance, if the base was 150, that time this side base will be how much? Corresponding value. Corresponding value means 138 এর জন্য যেহেতু 13.8 আসছে, what about for 150? কতর জন্য 150 আসবে? বুঝতে পারছি?
Yes, sir.
So maybe 15 kilovolt, maybe something like that. So that's why you have to calculate if your V base is this much That means for your circuit A, VS will be 10 times less. That means divided by 10. Here the base will be 2 times less, right? So here the base is 138. Here the base will be 69. Okay. Fortunately, আমাদের এখানে যা voltage আছে, whatever the voltage we have here and the base are same. That's why this value is equal to this value and this base value equal to the actual value, right? So what about your R actual? 300 into 138 divided by 69 square equal to 1200 ohm. What about this one? What about this one? 1200 into 138 divided by 38, 138 is 13.8 divided by 138 square equal to 12 ohm. What do you mean by this? This one is pretty important to understand. How we got this? See, where is our 300 ohm load? Where is our 300 ohm load? Here, right? In what side?
B.
In C, in C side, right? So
Yes,
for C, the resistance is how much? 300 ohm. What will happen if I shift this to our B side? Then what will happen? Then what will happen? You will have to convert that. Convert how? 300 into 138 divided by 69 whole square. This was the formula from where? From here, maybe. Equivalent circuit. This one. Z of low voltage, voltage of high voltage, voltage of low voltage whole square is equal to Z of high voltage. That means, see,
power sim করে যেটা স্যার
yeah, exactly. So here you have to find out the resistance, right? Resistance of 138 side equal to, you have to give the resistance of 69 side, right?
yes sir.
Then the voltage of 138 side, that means 138 actually. Understood?
Yes,
voltage
sir.
of low voltage, that means 69. Understood?
Yes sir.
Whole square. So here you had 300. So let's write 300. Your value will be 1200. 1200. That means for 138 side, that means circuit number B, your resistance is how much? 1200. Understood, everyone?
Yes sir.
Okay, let's write it here. Let's write the circuit here. Let's write the resistance here, 1200. This is 300, this is 1200. Now, again, you have to convert this 1200 to this side, right? And this
1200 into 13.8.
this one is how much? This one is your high voltage side. This one is your what? Low voltage side. Again, the formula will be how much? Formula will be what? Formula will be this one. This one, right? So just opposite. Opposite means? Opposite means what? This LV will go there, or you just keep it here. Take this side.
So low-টা উপরে হবে।
হ্যাঁ, তখন তোমার লোটা উপরে হবে, হাইটা নিচে হবে। The low will be at the top, high will be at the bottom, right?
Yes,
So let's calculate. This one is 1200. So your Z, that is your R, this is 13.8. Or I can just write, this is our RA, because RA side, right? Equal to RB into V of what? V of A, V of B square. So your RB, that means your high voltage resistance is how much? 1200. Your VA, that is your low voltage, is how much? 13.8. VB, that means your high voltage is how much? High voltage side voltage 138 whole square, if you whole square it, you will get 12 only. Got my point? So if this 300 ohm is converted or it is changed to that side, it will be 1200. If the 1200 is goes from here to here, it will be 12. Got my point? এই লোডটাকে যদি আমি এখান থেকে এখানে সরাই দেই তাহলে সেটা 1200 ওহমের মতো ইফেক্ট করবে। আমি যদি এটা এখান থেকে এখানে সরাই দেই তাহলে সেটা হইতে হবে কত 12 ওহম only. Okay? That is the change of side. Actual, remember these are all actual resistance. Now your base resistance is how much? Base. What is your base resistance? Base will be kilovolt divided by kilovolt square divided by kilovolt ampere, right? Hello?
Yes, sir.
What is your Z base? KV square, right? Remember? Divided by KVA. Understood?
Yes, sir.
So here you got what? Here you got KV square. That means 69 square divided by KVA, because KVA is same for all sides. But the KV is different for different sites, right? So here your Z base is 476. Here your Z base is 1900. Here your Z base is 19 ohm. Now, if you find out the per unit resistance, actual divided by base. Actual is 300, base is 476. So 0.63. 1200 divided by 1900, 0.63. 12 divided by 19, 0.63. That means no matter what side you are, your per unit will be always same, right?
Yes, sir.
That is the beauty of per unit. So you do not have to worry about, okay, what is the voltage, what is the base, what is the blah blah things, a lot of things. You do not have to worry. So once you get the per unit, your everything is same. In every side, your per unit is same. Okay. So that is actually one simple math. Draw the impedance diagram. Let's draw. Oh, the per unit voltage of the load, right? They have said, where? Yes, they have said, determine the voltage regulation if the load is 66 kilovolt with the assumption that the voltage input to the circuit A remains constant. Voltage regulation. They said the per unit voltage at load terminal, we have to find out that first. So VT is equal to what? 66 divided by 69. Why? Why they have said that? See, determine the voltage regulation if the load is 66 kilovolt, not 69, because here our voltage is 69, right? But our load is taking 66 with the assumption that the voltage input to circuit A remains constant. Okay? So আমাদের circuit A তে 13.80 আছে, সমস্যা নাই. It is constant, but our load is taking 66, not 69. Okay? Now we have to find out the voltage regulation. So your per unit voltage at load terminal will be what? Your actual divided by your base. What is your base for this circuit? What is your base? Remember? আমরা বলছিলাম কি? This is 138. That is the base. This is 69. That is the base. That is 13.8. That is the base. Where we have written this? Here. Right? There is the base. Understood? Now what is the actual?
স্যার এই 69টা
বলো।
হ্যাঁ স্যার 69টা আসলে করতে গেছে স্যার 69
কোথায়? এটা
স্যার এই যে স্যার জি স্যার
এটা কোথা থেকে আসছে?
স্যার 69টা জি স্যার
এটা কোথা থেকে আসছে?
এটা আসলে কিভাবে স্যার? জি স্যার
এটা আসবে কেন? এটা তো ওখানেই ছিল। দেখো এখানে আমি লিখছি 13.8, এখানে আমি পাচ্ছি 138, তারপরে এই 138 তো এখানে 138, তারপর এটা 69, ঠিক আছে? আর আমরা বেস ধরে নিছি এই সাইডে 138।
জি স্যার বুঝতে পারছি।
এখন আমাদের 838 হচ্ছে আমাদের বেস, আমাদের অ্যাকচুয়াল ভ্যালুটাও হচ্ছে 138। তার মানে কি আমাদের এখানে 69 ও আমাদের বেস 69, বুঝতে পারছেন?
জি স্যার বুঝতে পারছি।
কিন্তু এখন বলে দিছে সেকেন্ড কোশ্চেনটাতে বলে দিছে যে যদি আমাদের 66 কিলোভোল্ট আমাদের হচ্ছে অ্যাকচুয়াল হয়, মনে কর 69 না, আমাদের 66, এটা ডিফারেন্ট ম্যাথ, এটা এক ম্যাথ না, it is a different math. If our actual value is 66 kilovolt, then deal with it. Okay, তাহলে আমাদের পার ইউনিট ভ্যালু কত হবে? What is the per unit value of voltage of load terminal? 66 divided by 69, because 66 is our new actual and 69 is our base, right? So 0.957 per unit. The load current কত হবে? What is the load current? Load current will be per unit voltage divided by per unit resistance. Wait a second. Okay, so our base voltage is 69 kilovolt. Our actual value is 66 kilovolt. Now our per unit will be 0.957 per unit. Again, the load current will be what? Your load current will be, oh, by the way, it is per unit. Remember, this is per unit, because we know our per unit voltage, we know our per unit resistance, so we can find out our per unit load current divided by Ohm's law. According to the Ohm's law, V divided by R. So this is 1.52 per unit. That is our load current. Okay. Now the input voltage, how much will be our input voltage? V in is equal to 1.52 J 0.1 plus J 0.08 plus 0.957 equal to how much? 0.957 plus J 0.274 is equal to 995 per unit. Okay, how you got this? How you got this? এটা কিভাবে আসলো? এটা কিভাবে আসলো? That is our question, right? Why this is called input voltage, right? এখন সেটা যাওয়ার আগে let us draw the what? Let us draw the rectify. What is that called? Impedance diagram. How can you draw the impedance diagram of this circuit? Anyone? Abdullah?
Yes, sir.
বলতে পারবে এটা impedance diagram কেমন হবে? See, this impedance diagram will be, see, you have one transformer, right? Not impedance, draw the reactance diagram, okay? Draw the reactance diagram first. So you have one reactance for one transformer for this one. Then you have another one for this one, right?
Yes, sir.
Then you have what?
And resistor.
Resistance, right? That's
Yes,
it.
sir.
Because you do not have any transmission line, you do not have any what is that? Generator, do not have any motor, just these three things. Now, what is the value of these three things? This one is 300 ohm, but you have to write it in per unit. What is the per unit value? Remember, 0.63.
Yes, sir.
What is the reactance of this one? 10%, right? 0.1. 10% means 0.1. What is the reactance of this one? 8%, right?
Yes, sir.
Percent means point, right? Percent means what? Point. 0.81. Why J? Can anyone tell me why I have given J?
Sir, inductor.
Reactance, exactly.
Yes, sir.
Reactance. That's why. Now let's come down.
স্যার এখানে তো দুইটা স্যার ইয়েতে ছিল না, সব প্যারালালে ছিল না স্যার কানেক্টরটা।
হ্যাঁ, তো
স্যার দুইটা শ্রেণীতে নিয়ে নিলাম যে আমরা।
শ্রেণী মানে কি সিরিজ?
জি স্যার, সিরিজে নিয়ে নিলাম।
আচ্ছা, প্যারালালি হলেও আমার ট্রান্সফর্মার গুলো তো প্যারালালি কানেক্টেড হয়, তাই না? প্যারালালি হলেও আমরা
স্যার,
কিভাবে
বুঝতে
করি? আমরা এটা তো সিম্পলিফাইড, আমাদের তো এখানে আরো কম্পোনেন্ট আছে, মনে আছে?
জি স্যার, জি স্যার,
মনে আছে নাকি মনে নাই বলো?
মনে আছে স্যার,
হ্যাঁ, ওগুলো তো আমরা ইমপ্রুভ করে ফেলছি, মানে কি বলে ওটা কি বলে নাম?
বাদ দিয়ে দিয়েছিলেন।
হ্যাঁ, আমরা তো বাদ দিয়ে দিছি, নেগলেক্ট করে ফেলছি। নাও থিংক অ্যাবাউট দিস।
গ্রাউন্ডটা স্যার মনে ছিল না,
হ্যাঁ।
গ্রাউন্ড কানেক্ট তো খেয়াল ছিল না।
Now think about this. Here your voltage is how much? Here your voltage is how much? How much voltage you have here?
6.9, sir.
No, no, no. The voltage is 957. Here your terminal voltage is 957. That is your load terminal, right? Voltage. You have to find out what is your input. You have to find out what is your input. Now again, I'm going to give you these. Here, your output voltage is 0.957. What is your input voltage?
কেভিএল।
Not
Yes,
KVL, not exactly KVL. Because তুমি দেখো, তুমি এখানকার ভোল্টেজটা জানো, right? You know the voltage. Do you know the current? Do you know the current?
স্যার এখানে হলো স্যার ভোল্টেজ ডিভাইডার রুল দিব স্যার।
Voltage divider rule দিবা, but তুমি তো এটা জানো না. You do not know this. But do you know the current?
নো স্যার।
You know the current.
ও ইয়েস স্যার।
1 point
আর ইউনিট আছে তো।
per unit, right? You know
Yes,
the
sir.
current. Now here, this current will come from where? Definitely from the input, right?
Yes sir.
Definitely from the input. Now, what is the voltage here now? What is the voltage here now? Can you find out?
Yes sir.
Then can you add this one, and this one
Yes sir.
to find out the VI? Can you find out?
Yes sir.
Okay, what is the voltage of this one and this one?
0.1 into 1.52. J 0.1. Yes sir. 0.8.
This is the voltage of these two, right? Then what is this voltage? Right? This is your total voltage VI. বুঝতে পারছো না পারো নাই? Get
Yes
it?
sir. বুঝতে-
Ibrahim,
Yes.
Shoaib, you get it?
Yes, sir.
Okay.
Yes sir.
Now, if you do this, you get something like this, right? Now, if you do these in the unit calculator, you will get something like this. How you got this from these? How you got this from these? Okay? How? Any explanation?
Sir, এটা কি ম্যাগনিটিউড?
Anyone else?
Sir, polar form in
There
reactive.
is total reactance, sir, please.
What?
Total reactance, sir.
What?
Total impedance হবে, sir.
No. ওই আব্দুল্লাহ ঠিকই বলছিলা তুমি, ঠিক আছে? সেটা হচ্ছে যে এটা বেসিক্যালি তোমাকে পোলার ফর্মে নিতে হবে। পোলার ফর্ম মানে ম্যাগনিটিউড, রাইট? সো দিস ইজ ইন হোয়াট ফর্ম? দিস ইজ ইন A plus JB.
IB.
That means it is in rectangular form. Once you convert that into polar form, you will have something like this, R
থিটা।
angle theta, right? So let me
Yes.
do it for you. Let me do this for you in front of you actually. I'm going to turn on my calculator. Here, I'm going to set the mode to complex. Then I'm going to write it 0.957 plus 0.274 because you have to give the I later, right? Not first. But J, you have to give it first. Now here, if I click, this is your what? This is your A plus JI. I want to convert these to what? I want to convert this what? To polar form. Shift, complex. This is the polar form 3. Got it? 0.995 angle will be 15.97, right? But we only want what?
Maximum.
We only need the magnitude, that means the R, the value of R. We only need the magnitude. So 0.995 per unit. Understood, everyone?
Yes, sir.
Now that is your input. So what you have done, you have given these input, but you have got these output. So which one is bigger? This one is bigger, right?
Input is here.
So what happens to the other? That means what happens to the rest of the voltage? Ki hoise? That is the loss. That is the what?
Loss.
Loss to where? Koi loss hoise segula?
So load,
No, that is the
No,
loss to the
transformer.
transformer. Exactly.
Transformer.
Transformer loss hoise. So what is the regulation? Regulation means how much voltage you have given and how much you have got. That is called percentage. So input minus output divided by input. No, not input. It's output. Yes, sir, output.
Yes, sir.
Input minus output divided by output into 100%. Okay. So you got 3.94%. That is called voltage regulation. বুঝতে পারছি?
Yes, sir.
That is called voltage regulation. Now, how much voltage regulation is allowed? Do you know that? Abdullah, Ibrahim, Saidul,
No,
Yes,
sir.
sir.
কত percent voltage regulation allowed? How much? What is the maximum amount of voltage regulation that is allowed?
We don't know, sir.
Hey, who took your transmission and distribution course?
আপনি নিয়েছিলেন, স্যার।
So,
স্যার
okay,
আপনার কোর্স ছিল, স্যার।
let me show you. আমার কোর্স থাকলে তো আমি পড়াইছি 100% শিওর আমি, তাই না?
ভোল্টেজ রেগুলেশনটা হইছিল, পড়ানো হইছিল, স্যার।
That is 100% sure. 100% sure আমি তোমাকে পড়াইছি এটা. Let me. Yes, here. এটা আমার নতুন নোট. This is my new note. But in case of your course, I have explained what is the voltage regulation. Voltage regulation should be plus minus 6%.
6%, জি স্যার।
মনে আছে?
জি স্যার।
You forgot. Plus minus 6%. That was the
20 ভোল্টেজের সাথে প্লাস মাইনাস 6 দেওয়া ছিল।
হ্যাঁ। Okay? So I know I have done that because this is in my list. আমি জানি এটা করাইছি আমি। But ভুলে গেছি.
Yes, sir.
So it is within the range, right? Plus minus 6% was the permissible. The permission আছে plus minus 6%. But here it is less than 6%. So it is good. Okay? It is good. No problem. So 3.97%. সাইদুল, সিনেমা হলে পরে বসে ক্লাস করো নাকি? যেই শব্দ হচ্ছে। Okay. Now let's move forward. Load calculation in per unit. We have to calculate the load in per unit. Load can be modeled either series or parallel. Load can be modeled either series or parallel. To model load as series, RPU will be V square divided by S cos theta. XPU will be V square S sin theta. Remember, cos theta will be your actual load, that is your real load, that means resistance, and your sin theta will be with your reactance X, right? To model load as parallel, তুমি যদি parallel load কে model করতে যাও, if you want to model the load as parallel, so your cos theta will be at the bottom, not at the top. This is where এটা কিন্তু উপরে আছে, cos theta is at the top, right? Now it will be at the bottom. And sin theta was at the top. Now it will be at the bottom. Okay, we will see what is it, what this is. The given information of a load are 250 MVA, 0.8 lagging power factor, operating at 132 kV. The base at load terminal is 200 MVA and 150 kV. Determine the per unit resistance and the reactance of the load for the following cases. Load modeled as a series, load model as a parallel. এটা সব তো ইম্পর্টেন্ট না, but yet we will do that. তোমাকে এখানে বলছে কি, তোমাকে এখানে S দেওয়া আছে 250 MVA and your power factor is given 0.8. That is your cos theta, remember, not sin theta. That is your cos theta. Power factor lagging, operating at 132 kV. That is your voltage, and what? Remember, that is your actual voltage, not your base voltage. Actual voltage. Now you have to think your base is 200, not equal to your actual. See, they are different, right? This is your actual, this is your base, 200 MVA, and this is your actual, this is your base kV. Determine the per unit resistance, per unit reactance for the of the load for the following cases. তুমি একবার সিরিজ হিসেবে মডেল করবা, একবার তাকে প্যারালাল হিসেবে মডেল করবা. So you have to find out the voltage per unit first, S per unit first. Cos theta is already given. You have to find out the sin theta, right? Got my point?
Yes,
Why?
sir.
Yes, sir.
Because you need voltage per unit, you need S per unit, you need cos theta, and you need sin theta. In all cases, right? These are the 4 things you need. So let's find out the voltage per unit is equal to base, no, actual divided by base. What is your actual voltage? 132. What is your base voltage? 150, because it is saying the base is given. So 0.88 per unit. What is your SPU? Actual divided by base. What is your actual? 250. What is your base? 200. So 1.25 per unit. What is your cos theta? 0.8. Now what is your sin theta? That is a bit tricky because you have to find out the theta first. Right? This is the theta. Theta is equal to cos inverse 0.8. So 36.87. Now you put that into the sine, then you got 0.6. Okay, everyone? বুঝছো এটা কিভাবে
Yes, sir.
করছে?
Yes, sir.
Yes.
Normal trigonometry, right? You know it.
Yes, sir. We know.
So from here you will find out the theta, then put the theta into the sine, then you will get 0.6. Now everything is done. Now you find out the RPU, XPU, RPU, everything is same, parallel and series. Series means what? They will be in series. Your reactance and your impedance will be in series. And parallel means what? Your reactance and your impedance will be in parallel. Normally, which one is the case? More commonly used case. Which one is the most commonly used? Series. Series is most commonly used. Okay, but sometimes it can happen. I'm going to give you parallel. Okay, so you have to use cos theta sin theta at the bottom. So this one is not that important. Okay, not that important. Okay, this is called changing the base of per unit quantities. Changing the base of per unit quantities. If your base is changed, then what will happen? When only one component, such as transformer, is considered, the nameplate rating of the component are usually selected as base values. When the several components, such as generator, transformer, transmission line, load, etc., are involved in the circuit, however, the circuit base values may be different from the nameplate. Wait a second.